Object oriented principles, list of object oriented principles, classes, objects, encapsulation and abstraction. Okay, now we are going to see these are the pair. Next pair of elements are going to start. So we are going to start. This pair of elements will start. First, I will start with inheritance. We will start. First, we will start with inheritance. So actually, it is a combined topic, that is inheritance and polymorphism. Both of them I have to discuss at a time, but I will discuss separately this part. So first we will discuss inheritance concept. Later we will go for polymorphism, we will go. And inheritance and polymorphism combined topic we will discuss. Okay. So with this, what is the index we are going to discuss? So there I am going to discuss purpose of inheritance, why we go for inheritance concept, we'll go for it. And next we are going to discuss about another concept is advantages of inheritance, nothing but advantages. I'll take advantages of inheritance, and before that I will discuss definition of inheritance, and next we will go for advantages of inheritance, and next followed by types of inheritance, and before that I will go for memory management in inheritance. Memory management in inheritance, this is before the definition only I would like to see. Advantages of inheritance, types of inheritances I am going to discuss. Out of that we are going to discuss 5 important varieties of inheritances. That is single inheritance. Second is called what you know. I'll take multi-level inheritance. We will discuss in this class multi-level inheritance. Next we will talk about hierarchical inheritance. And we'll talk about next multiple inheritance. Next we will talk about hybrid inheritance. Right? Followed by next programming example. Next I will go for syntax for inheritance. That means how to inherit the things. Followed by programming examples on this area. Programming examples. This is the topic of inheritance completely. And we'll see multiple examples. After that, followed by, before going to this inheritance, after completion of this inheritance, we will discuss about method overriding. Where before going to polymorphism, we'll discuss method overriding. So this is very important. Method overriding, that I will explain separately after this inheritance. So let's start with inheritance mechanism now. So we'll start with inheritance importance. So let us take a small example here. I will start with a certain example. Let us go to the diagrammatic representation. According to the discussion which we made so far, the Python code can be written in how many ways? 2 ways. One is by using functional programming, one more by using object-oriented programming. 2 models of programming is there. In the functional programming, how we used to reuse our variables and functions? By using functions, next modules and packages. And we have already seen in our classes. Functions will provide the reusability within the same program. Modules will provide reusability across the programs, provided they is present in the same folder. And when we come to packages, we can reuse across the environments, folders, and everywhere else. Right. Now, when we come to the object-oriented programming, When we come to the object-oriented programming, where are you writing functions? Quickly, it is very easy to understand. Where are you writing functions? Inside the class. So DEF function 1, for example, function 1 of any type of function you take it, of any type of function you take it. This is called one function, right? DEF function 2 of self. This is called one more type of function, which are called what? Methods in our object-oriented programming. Where are you writing them? Inside of the class. Inside of the class. What is my class called? Test. Test is my class. Inside of the test class, what I am having? Methods are there. I can take even inside class level data members I can take. Inside instance data members I can write. Constructors I can write. Everything I can write it. This is called one type of class, which is containing functions are there. fun1 and fun2. Two varieties of functions are there. Suppose now I am writing one type of class here. Class called sample1. Carefully listen. It is very easy to understand now. Once we know classes, other kind of OOPS features are very easy. Sample1. Sample1 class is containing some more functions are there inside of it. DEF, some method M1, some logic is present inside. Now I am going to say, in this class called sample1, in this class called sample1, what I would like to do? I would like to use function 1 and function 2. What we will do? I would like to access function 1 and function 2. What should we do? In the previous case, one example I told you. What is that example? We created an object of test class inside of it, sample1. Last class only, before ending the class I said. Create an object of which class? Test class inside of that and call what? Functions. Okay. Suppose there is one more type of class is there. Carefully try to follow. One more type of class is there. What is that class here? Sample2. Another type of class. Class called sample2. In that also, I am having one method. What is the method here? Method 2 of what I am having? Self. Having some logic. Again, this class also, I want to use this F1 and F2 methods. Again, I need to create an object of what? Test class. So like that, I am having one more type of class like this. That is sample3. Sample3 class. I am taking sample3 class. Let me take sample3 class. Carefully, if you follow, in these classes, I am having requirement of calling those methods. Which methods I am interested to call? Function 1, function 2, function 3 are the functions present into test class, which I would like to access into the respective classes called what? Sample 1, sample 2, sample 3. What is the last class? One small example I told you. In this class, create an object of which class? Which class? Test class. Create an object. How do you create an object here? T1 is equal to what? Test of. Because of that, what is created? Memory space created or not? And I am going to call it as what? T1.fun1 and T1.fun2. I am writing. T1 dot what? fun2. This is what I am going to call it. So let us go to this place also. There also you are creating again. Is it not called waste of memory space? Come on, quickly try to understand. Is it not waste of memory space? 3 times I created an object of which class? Test class. It is unnecessarily taking memory space for test class again and again. I don't want this memory space to be taken these many times. These many number of times I don't want to take it. How many times I want to take? Only one time. For that, we will apply today. Inheritance concept we will apply. What is the concept of inheritance? Inheritance concept says that neither we write the source code for this function 1 and function 2. In which class? Sample 1. nor should not take the memory space, but they should be available as it is. If I create an object of test class again and again in many places, it takes lot of memory space. Then what is the next procedure in front of me? Another procedure is define the function 1 and function 2 again and again in these places. That procedure also I am not interested. Why? Writing the function 1 and function 2 in this place, function 1 and function 2 in these places will take lot of time or not? That also I don't want. So neither I don't want to define the function definition, nor I create the object of which object? Test. But I want to get those functions definition as it is without taking memory space, without writing the physical source code. That is only one and only one solution in OOPS called what? Inheritance. Did you understand what is the inheritance? In OOPS, if I want to reuse one function of one class into where? Another class, I must go for what? Inheritance. What is the principle there? Inheritance principle I must apply it. Are you able to understand? So why we go for inheritance? In functional programming, we will use functions for reusability in the same programming. We will use modules for across the programs of same folder. Packages will be across the environments and folders and everything. And in OOPS, how do you reuse from one class to another class? With the inheritance mechanism. Let us go for one more generalized situation. Let us go to the product-based things. You take it. OS evaluation, you take it. Operating system evaluations, you take it. Operating system development scenario, you observe it. Development scenario. Try to understand some examples. Here, first operating system came into the picture. DOS operating system came from Microsoft. DOS-based operating system came from the Microsoft. Later on, what they did, they developed Windows 95. What is happening here? In Windows 95, what is happening? All the features of DOS are coming to where? Windows 95 plus some new features are only developed in where? Windows 95. I hope you are following me. Next after that, what is coming? Windows 98 came into the picture. What is Windows 98 contains? Windows 98 contains new facilities are there and they are carrying the old features. That means they are enhancing the old products. Windows 95 enhanced. That means added something new and brought the previous things as it is. Without investing anything, they are bringing this Windows 95 features as it is, adding new thing extra. And then after that, what is happening? A new operating system came. That is nothing but what here? Something like, Windows 2000 came into the picture. For example, in Windows 2000, what is happening? Windows 98 facilities are coming. Some extra features are added. What is the meaning of this? If I go on taking, as on today, so many number of Windows evaluations are there or not? So what is meant by that? What is the meaning of it? What is your understanding with this? We are reusing the previous code, what they developed it. In the current development or not? In the current development, we are reusing the features as it is. We are getting the things from previous development into the current development. What is this mechanism they are following? Which mechanism they are following? Inheritance mechanism they are following. That means in all sorts of development, Windows DOS-based features are coming to Windows 95. 95 features are carrying into 98. 98 features are carrying into 2000. And like that, Windows 7, Windows 8, Windows 9, and Windows 10 and Windows 11. Is it not called inheritance principle is followed internally? Take mobile development also. Mobile devices development also. Mobile devices. You know better than me how the mobile devices are. To take any iPhone, you take it. There are so many number of versions are there or not? So what they are doing? Previous features are carrying and extra features they are adding. Like that, if I take it the mobile developments, if I go to the picture of this, If I come to our example part, what I am trying to say, the class test is having some type of code which is reusable for many number of other team members. Those team members are requested to reuse the function 1, function 2 of which class? Test class. When they reuse that function, test 1, test class, function 1 and function 2, which type of burden is reduced from sample 1, sample 2, sample 3? No physical source code is taken, no physical memory space is taking, plus no need to write any type of certain code by yourself. So is it not called advantages? So let us take one small example here. A very small example I would like to show you. Just for a minute you see. Direct first example I want to show you. Let us just watch it. A small example I would like to place it. Class, something like an operation. Something like an operation. What is an operation I am going to give you here? A small, very small example. DEF, add OP of A comma B. A comma B. Print of, I am taking sum of, I am just taking something like this, is equal to, like this, dot format of A comma B comma A plus B. This is my class. Finished. This is my class. And class, one of the student called what you know? Ravi. The class Ravi want to use sum of two numbers. What he will do? He can't write the same code once again. If I ask the Ravi to write the same code once again, is it not wasting the time? Next I am writing class Mohan is one more student. I am asking to write the code once again. Next I am writing class something like Rajesh is another software engineer. I am asking to write the code for what? Sum of two numbers. How many classes I am having? 3 classes. These 3 classes requiring this operation or not? Then would you like to ask them to write every time or not? Would you like to write every time? Would you like to reuse? I would like to reuse. To reuse the functions, variables and constructors of any class into another class, which concept I have to use? Inheritance I have to use it. Suppose if I make them to write again and again, is it not taking waste of time? Is it not waste of time? Look at that. I'm going to write once again they are writing and once again they are writing. It is just called what? Waste of time. It is just a waste of time. And moreover, the same code is written again and again. It takes lot of development time. Instead of that, it is taking lot of time. Instead of that, I will just remove. So Ravi is the person want to take the things from which class? Operations class. What he is doing? I will write. Directly I am writing the coding. What I will write it? Operation. What is operation? Is the class giving the features, giving the data members and functions, methods. In which class? Ravi. So I will just write pass. Which function came? Add function came. So Mohan also want to take from the same place. What is this now? Operation. Right? Just I will write pass. And Rajesh also want to take the same thing. Operation. And just say called what? Pass. Create an object of what? R is equal to what? Ravi. R dot. What is the function name I am calling? 10 comma 20. He did not write, but he is calling that. Are you getting my point? Next I am going to write what? Create m is equal to what here? Mohan. I will write it here. M dot add OP of 100 comma 200. Next is called what? R1 is equal to what? Rajesh. I am just writing here. R1 dot what? Add OP of something like 3 comma minus 4. 3 comma minus 4. Minus 3 comma minus 4. Whatever you like it. So what these people are doing, guys? Are they reusing or writing again and again? Reusing. Which concept? Inheritance. Let us see. Actually, it is so simple. Once a class and object is clear, all these things are very simple. Look at that. INHPROC1.py. Just execute it. Just execute it and then see, then I will go for the concept part. So go to that, I'll go to this place, I'll go to this whoops, inside of it, I'll create what? Inheritance. Inheritance I will create. Inside of it, I will save my code. My program name is inhproc1.py. Go to the command prompt, go to this place of here, I'll say like this, E colon. So Python here, I say 4 p.m. So CD here, what is this now? Oops, right. Come on, next, CLS, and say next is called what? Inheritance. Then I will go for showing this. Okay. So now I will say PY, see students, PY, I say, our program name is this one. So I'm going to get it. What happens? Yeah. So it is going to be taken as what? Self. You forget that. I also forget. Not saying anything. So it is going to be given what? Are you getting the output or not? How many times function is defined? One time. How many times I am reusing? So it is called a great advantage or not? So this is called a great advantage. Suppose you see this code, I will write it in another place. This is one thing. Let it be, leave this. I will take one more type of code. Look at this here. See how I am going to introduce. This part, you see, you take this example, cancel this. This is called inhproc2.py. inhproc2.py or something like op.py. op.py. Save this code. Save this code for a minute. I'll go to this inside of it. So here, E colon, go to the location of it. Under whoops, under what, inheritance, and say paste this op.py. And I will go to the main program. In the main program, I will create it. In the main program, I'm going to create it. Let us go to the main program. I'm trying to take Python here. Look at that. I'm writing like this. I'm writing Senapati, Seema Senapati. These are formal parameters. I am writing directly. No need to write self.a, self.b. If you write self.a, self.b, you will get error. I am using directly formal parameters here. Okay, now? Right. So coming to this place, here you see, I am going to say, come on here, error is coming now, you see. Inheritance proc2.py. What is an error? Operation. Operation is a class. Is it present in the same program? No. Yes. Asif, correct. Name error will come. Name error. Let us execute. Let us execute. Py inhproc2 name error. Which one is the name error? Operation. Which was present in where? Another program. In the form of a class. How can I reuse the class from one program to another program? Through modules. Modules in whoops. Modules in functional program. So simple. From OP. Where is that OP? OP. This is called file name. This is called a file name. And acts as what? Module name. Module name. So let us go to this place. I say inhproc2 from OP import operations. Very good. Import operations. Operations. Now you see, you will get perfect answer. So any number of people, I defined my class one time, I can reuse these functions anywhere else. So it is nothing but inheritance concept is going to give you what here? Inheritance concept is going to give you what? Once if I define my code one time, I can reuse the same code again and again, many more times. So inheritance in whoops is meant for reusing the features of one class into another class. What are those features? Data members it can be, methods it can be, constructors it can be. Are you following that? So I'm going to introduce what is that introduction to the inheritance. I'm going to enter into that. What is the purpose of inheritance? What do you understand? The purpose of inheritance. The purpose of inheritance is that to build which applications? Reusable applications. Reusable applications in Python programming, because it is one of the inheritance is one of the distinct feature of OOPS. Inheritance is one of the of course I already wrote it, distinct feature of OOPS. Distinct feature of what? OOPS. And with inheritance, what type of things are possible? Reusability is possible. Non-object oriented reusability, functions, modules, packages. Class to class reusability, only inheritance is possible to reuse. I can reuse in another way, create an object of one class in every class. But because of that, what is happening? Memory space is wasted. But because of inheritance, no memory space will be taken it. Understand? So coming to the point of it, reusable applications you can build. Reusable applications you can build. Right? Next, I am giving the definition of inheritance. Definition of inheritance, I am going to take it. So I am going to take it. Definition of inheritance. How do you create? How do you define this? Come on, ma. How do you create? I am going to give you the definition. The process of obtaining data members, comma what? Methods and what? Constructors. That is nothing but known as what? Features of one class into where? Another class. Into one class into another class is called what? Inheritance. Is called inheritance. People will ask you, then in functional programming also we reused it. There no classes concept is available. Here customized classes are written, customized functions are there. We want to reuse those functions from one class into another class. That's why we will go for inheritance. So here some terminology you need to get it. What is the terminology you are getting? Data members, methods and constructors of one class into another class. The class which is giving, I'm writing here, the class which is giving what? The data members and the methods. Data members and what? Methods. The class which is giving data members and methods is called what? Super or base or parent class we can call. Parent class. Slowly we are going to get everything into most perfectly. Fine. Next is called what? The class which is taking what? Data members, methods and constructors is called sub or what? Derived or what? Child class. Did you understand this point? The class which is giving data members, methods and constructors is called super or base or what? Parent class. The class which is taking data members, methods and constructors is called what? Sub or derived or what? Child class. Are you getting my point? Fine. And moreover, one more point I need to say. What memory management it follows? Here two things are there. Two things people will ask a question. You come to this. I want to use function 1 and function 2 of test class into sample 1, sample 2, sample 3. What is the first way I applied? Create an object of test class 3 times. 3 times memory space is taken. More memory space definitely gives performance problems. One more way is what? I am trying to write that function one function definition again and again, again and again. Many more times I wrote it. 2 times I wrote in the first place, 2 times I wrote in the second place, 2 times I wrote in the third place. Is it not writing 6 times waste of time? That also I don't want. What I am expecting? I am expecting that function 1 and function 2 be written in one class test, same type of functions. I want to get them into sample 1, sample 2, sample 3. Neither source code writing nor memory space taking. That is known as what? As it is that is available, neither we write source code nor they takes memory space, which is known as what? Logical memory management we can call. What is that memory management? It's a very important question in the interview point of view. How many ways are there to reuse the features of test into sample 1, sample 2, sample 3? First way is what? Create an object of test class in 3 places. More memory space. I don't want that. Another one is write the same logic again and again. More lines of code. But I want to get the same code as it is into all these classes. Sample 1, sample 2, sample 3. Only one and only solution, that is called inheritance. So inheritance says that get everything from test class into sample 1, sample 2, sample 3. Those things are available as it is. How you can call? Like how you can call the normal methods, like that I can call the base class methods also. So which memory management it follows? Logical memory management. So I'm writing one important statement. Inheritance concept always follows what? Logical memory management. Logical memory management. What it says, this memory management says that this memory management says that neither we write which one? Source code. Neither we write source code nor takes what? Physical memory space. Physical memory space, that is nothing but what, in simple normal terminology, free of cost. Neither we write physical source code nor they takes memory space. It's really a greatest advantage. So nor takes a physical memory space. This is a slogan of which concept? Inheritance. In a simple word, in a normal life level example, if you take it, if you born first day, your parents already earned something, they give to you directly to you. They work for a long time and they are giving directly their properties to you. It is nothing but neither you work nor you earned. You are getting as it is from your parents. It is known as what? Life level inheritance. In physical software development, already I developed hundreds of lines of code, thousands of lines of code. I spent for 1 year. I developed so many kind of logic. That logic I want as it is to enhance my project. Enhancing means what? Something I want to add new by carrying the old one. What is that concept called? Inheritance. So I hope that up to these lines you understand. Up to these lines you understand. So let me speak for 2 seconds with online students. Online students, did you understand this? Did you understand, students, all of you? Quickly try to confirm it, students. Right. Fine. So, Shravani, can you please ask other students to switch off their camera? Okay, disturbing. Okay. So let me see. Rakesh, you switch off your video, ma? Yes, ma, I told them. Okay. Okay. Right. Lakshmi, so when we have inheritance concept, then what is the benefit of using data abstraction? Lakshmi, data abstraction, inheritance, nowhere else related. Nowhere else related. Am I correct? So, for example, you take nowhere else, first of all, there is no link at all. First of all. So I hope that, I think she might be understanding that. Line number 15, error. Okay. Nor. Okay. Ganesh Kumar, thank you. So nor takes See, you are all just observing. Ganesh Kumar, you see, is correcting me. It's really good. Right, Ganesh Kumar? Neither we write the source code, nor we write like this. Yes, ma'am. Manjula. Yes. So I hope you are understanding this. Is it clear? Now, further, if you understand me, Lakshmi, did you understand, ma? Abstraction says that whatever I am giving to you, you will access. That's it. Encapsulation says that I am hiding something from you. That is known as what? Encapsulation, abstraction. That is, clarity is there. Here, inheritance says that what? Here also you can apply. You can hide here also. What I will do in this case, you come on to the point, I will write here what? Underscore, 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 I will write it. Will it be inherited? Will it be inherited? No. Why? I made a private. Private means what? Hidden. You can access inside of the same class, but you cannot inherit into where? Yes. That means what to give, what not to give, it is there in my hands. If I don't want to give something to you, I will not write underscore, underscore. Am I correct? So let us come back to students. This is called method encapsulation. Yes. Come on to the point, ma. Next, I will go to the next discussion. Right? So coming to this next, Renuka, what is that your doubt, ma? Data abstraction is for accessing the unhidden data, and the next to encapsulated data, sir. Yes, correct. Exactly the same thing. So unhidden data means open data which I am giving. It's a open data. Hidden details, open details. Hidden details are nothing but underscore, underscore properties are called hidden data. Without underscores data is called unhidden data that we can access it. Correct, ma? Renuka, correct. What you are thinking is correct. Next, I will go to the next part of it. Advantages of what? Inheritance. Very, very simple. Advantages of inheritance. Let us see that. Yes, ma? Brahmani. Print statement. Why we not using self, ma? Yes, ma. Please look at, ma. I told already. Once again, I will say. Here, Brahmani, you are asking this statement, ma. What is this AB? Formal parameter values. Actually, you are expected so far what? Self dot A is equal to A. Self dot B is equal to. Self dot B is equal to B. That time I can write what? Self dot A is equal to self dot A, and next what? Self dot B, and next what? Self dot A, and next is called what? Self dot B. I can write happily, no problem. You execute once again, INHPROG2, same output is coming. But today, what I am not writing, I am not keeping in object. I am directly adding the formal parameters only. If I write self, that will add to the object. But here what I am doing, only one operation is there. Directly I will perform the operation. I need not to write this kind of self-related things. That is what I am trying to feel it. That is what I am trying to feel it. Brahmani, did you understand, ma? These are all called formal parameters. No need to use any type of self there. Brahmani, did you understand, ma? So, yes. Now I will continue further. Still, lot of examples you will come across, ma. No problem. Advantages of what next? Inheritance I am going to say. First advantage, when we develop, I am writing one small statement. When we develop any inheritance-based application, we get the following advantages. So many times you will come across these things. What are the advantages of inheritance? Compulsory question it is. So the first question I am going to write it. Right? Now I am going to write it. First point is what? Application development time is. You try to understand and then say application development time is less. Am I correct? Why? As a teacher, I will write my code once. All my students will reuse my function. You need not write my definition once again. Is it not development time is less? Fine. Second advantage is what? Once your development time is less, definitely application takes which memory space? Application memory space is what? Come on, fast. Is what? Less. Why less? Because I wrote my statements only once. When they are coming to you, they never takes any memory space. Felt that they are available, but in reality, the same code is not written by you. That's why space is less. And the next point is, third point, if you say application, come on, now I am writing application, execution time is fast. Execution time is fast. That is nothing but less. Fastest execution is nothing but less execution time. Are you following? Fastest execution is nothing but less time to execute means fast in execution. Next, fourth one is application performance is enhanced. Application performance is enhanced. Means what? Improved. Improved, this is called improved. Performance is improved. Why performance best? Actually, performance depends on how many factors. One is in the form of space. One more is in the form of what? Execution. These are the two factors where performance differs. Neither space is more nor time is more. Both of them are less in space and less in execution time. It is called what? Performance enhanced, this is called. Are you understanding? And next I am going to take fifth one. What is the fifth one? Redundancy of the code. Redundancy means what? Duplication of the code is reduced. If I say that addition, if I want to give to some 20 people, 20 times you need to write the same code again and again. So such a type of redundancy. Redundancy is nothing but what? Duplication. That is a repetition of the code. Is minimized. Is minimized. Did you understand? Fine. Redundancy of the code is minimized. Application development time is less. Application space is less. Application execution time is less. Application performance is enhanced. Redundancy of the code is minimized. These are the ultimate advantages of what? Inheritance. Whichever language supports this facility, all the languages will get these advantages. And Python also, one of the language supports what? Inheritance. So definitely these advantages are getting. Is it clear? So this is a regular question is asking, what is the definition of inheritance? One regular question. What is the purpose of inheritance? That is another question. In detailed answer of the purpose, advantages of inheritance is one more type of question. This is a concept based. Why I am going for inheritance? If somebody asks, you need to explain this. Did you understand me? Yes. So take a situation in software industry as a team leader. How many times I have developed the code? Once. And all my team members will reuse my code again and again. If it is a functional programming, I will keep it into package and I'll give to everybody. If it is a programming of what? Classes, I will give in the form of inheritance. Are you getting? Fine. In the same folder, across the folder, here also packages concept I can use. Oops with packages. We will see one example on that. Shall I continue now? Students who are in the online, did you understand this simple description here? Now, if you say, I will move forward. Very good. Now I am going to move to the next description. That is called what? Yes, ma, Ganesh. You said already now. Once you said already now, you are pasting 7th time this one. Post all the diagrams in nodes. I said I will post it. Beginning onwards I am posting now, Ganesh. This also I will post it. Okay na? Still lot of diagrams will come. When the diagrams will come, you will feel that these diagrams not necessary. Not necessary. Of course, this is not a small diagram for make to write in the notes. This is also not necessary. You will understand. I am going to draw some more diagrams very nicely. You will follow that. Right? Hmm? Yeah, Mahendra Babu, yes. So I will post this diagram. No, don't worry. I will take care of it. Fine. I will take care of it. So don't think like that. I will post it. Okay. Be careful. Keep your concentration on my explanation. Whatever I am describing, I will post it in the notes. In the fair notes, I will post it. Okay. Done. Now I am going to introduce how many varieties of reusable inheritances are there. How I am going to get it? I am going to give you the clarity. Look at that. I am giving one small clarity here. A general example I am going to give you so that technically you will collect to me. What is my example I am going to discuss next? Another type of discussion, types of inheritances. Types of inheritances. Before I am going to read the further programming, I need to discuss this topic. Types of inheritances. I am going to say. Let's start with the types of inheritances. Virat Kohli, switch off your video. Man. Rohit Jain, switch off your video, all of you. Right. So coming to the point of it. Next time, whichever video I will see, I will ask questions to you. Take care by yourself. Or I will remove from the meeting if you are not answering. Only two things. If you switch off your video, I will see you and I will ask the questions. If you don't answer me, okay, Rohit, no problem. No problem. Okay, good. Rohit is very good boy. Anytime anybody switch on their video, I will ask the questions. If you don't answer, I will give you rest. Today, Saturday, rest. I will give you rest time for you. Let us go to that. Now I am going to start. Careful. Because if you disturb me, so I will disturb you. If you don't disturb me, make me too smooth, I will not touch you. I will also explain explaining the subject. So don't disturb me. Let me continue my session. Look at, suppose general scenario I am going to talk. A generalized example before going to that is a parent and the child. Parent is giving the properties to child. This is called one type of inheritance. One type of reusability from parent to child. General example, normal example. Teacher to student. Teachers to student only. Okay. Next. One more type of that. What is that inheritance? I will explain. Don't worry. Next I'm going to talk about one more type of inheritance. One more type of thing. Look at grandparent, parent, and then you. And then you. Your grandparent earned so much, your parent also earned so much, both the properties are coming to you. This is called one more type of inheritance. Your grandparent also gave to you, so properties are coming from your grandparents. This is called one more type of inheritance. Well, one more type of inheritance. What is it? It is called a teacher. Teacher is giving to knowledge to student 1, student 2, student 3, student 4. How many base classes we have here? One base class. How many subclasses are there? Many subclasses are there. This is called one more type of inheritance. One more type of inheritance. Your LKG teachers, your UKG teachers, your college teachers, your engineering teachers, all the things are coming to your place. That's why you are super student today. So coming to the point of it, this knowledge, and all the knowledges, total knowledge is in you. That's why we are in very good, right? So remembering all these knowledges, remembering. Last I am also there. So I hope what you are remembering, I don't know. LKG, UKG, intermediate, engineering, Python, because Sar is there here, that's why. When Sar is there outside after going, Python you are remembering. Okay, Rocky, you are remembering Python. So there is nothing but what many teachers' knowledge is coming. This is called one type of inheritance. I will explain in detail. Next term, see that students here, I am having This is called one parent class, giving the distributing the properties to whom? Distributing the properties to two childs. One of the child is giving the properties to what? The another these two the classes are giving the properties to something else. This is nothing but what? Combination of different inheritances. This part is called hybrid inheritance, we can call. Which inheritance? Hybrid. First one is single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, and then hybrid inheritance. So I will go for explaining those things one by one in the class with a nice diagrams. So what is meant by type of inheritance? Type of inheritance is what? One type of pattern, first of all. Is one type of model. Very regularly asking question. What are the various types of inheritances in Python? What are the various types of inheritances in Python? 5 types of inheritances are there. First of all, what is the type of inheritance? I am going to give you. Type of inheritance. I am going to give you type of inheritance. Make type of inheritance is a pattern. Is a pattern or what? Model. Which makes us to understand how the features are inheriting. How the features. What are the features? Data members, methods, constructors. From which class? Base class into which class? Derived classes. Into derived classes. That is type of opinion given by the type of inheritance. Once again, type of inheritance is a pattern or a model which makes you to understand how the features are inherited from where? Base class into derived class. Such a type of patterns are known as what? Type of inheritances. How many types of inheritances are there? 5. So I am writing in Python programming, we have 5 types of inheritances. 5 types of inheritances. They are, what is the first one? Single inheritance. First one is called a single inheritance. And the second one is called what? Multi-level inheritance. And the third one is called what? Hierarchical inheritance. And the next is called what? Come on, next. 4. Yes, ma, derived class. K. Kumar. See, ma, already explained here. Please look at that. Kumar, you see. The class which is taking, Kumar, please look at ma. The class which is taking data members and methods and constructors is called what? Subclass or what? Derived class, child class. The class which is giving is called what? Base class. Suppose take a best example, teacher and student. Teacher is which class? Base class. Student in the class? Derived class. Simple. Kumar, did you understand, ma? Did you understand? Confirm it, student. So, next is called what? Hybrid inheritance. Now, something is missing. Multiple inheritance. That is, fourth is called what? Multiple inheritance. And the next to last is called what? Hybrid inheritance. These are called 5 types of inheritances. Now I would like to go for, yes, ma'am, Asif, exactly. But use the words called what? Base class or super class. Derived class or subclass you use it. Parent class and child class also we can use, but you give the preference for last. Now I would like to say, what is single inheritance? What is multi-level inheritance? I just want to explain with the diagrams. Okay. Look at that. So I'll go to the paintbrush. I will give you in this place a little colorful output I want to give it. So let us go to the first inheritance here. What is that inheritance? Single inheritance I want to explain. So let us go to the single inheritance here. So let me go to the single inheritance here. How simple it is. Now I am going to give you the single inheritance. So easy for us. Let us watch this example now. So single inheritance. So I am going to give you single inheritance here. Very simple. Now I am going to give single inheritance. Let us start. First, definition will be there, diagram will be there. I am increasing definition, and next is called what? Diagram. Definition will be there plus a diagram will be there. So now I am going to give you the definition. Before that, I would like to write a diagram also. Look at diagram. So by seeing the diagram, you can understand lot of things. Look at the diagram here. It is something like this. There is a class called C1. I will do the programming on this area because the first time covering concept. After that, syntax. Later, programming will start. Next, one more type of thing is there that is called C2. C2. So coming to the point back here, this is called what C1. I am taking C1, and below to that I am going to write it. What it is, C2 I will take it. C2 I will take it. What is C1 is called? What is C1 is called? Quickly. Base class or not? Base class. What is C2 is called? Derived class. C2 is called what derived class we can call. So DC. Subclass also we can call. Superclass you can call. You can call it. Suppose you feel any difficulty, this is called a subclass. I will write it. Subclass also called as what? This is called which class? Superclass we can call. Superclass or base class we can call. Nothing like that. I can understand this. Superclass we can call, or also called as base class. Such a type of diagram is called what? And I will write some arrow down. So arrow down or upwards, there is no issue at all. So if I write arrow down, you can understand that C1 features are inherited to C2. Or if I write the features up, C2 is getting the features from C1. C2 is getting the features from C1, only English. So in arrows, nothing is there inside of it. But I write the flow down. So that is easily understandable to the student. Tell me, my dear student, what is the single inheritance contains, ma? This inheritance contains, this inheritance contains, I am going to write it. Inheritance contains, yes, next, single base class, and what? Single derived class. Single derived class. Such a type of inheritance is called what? Come on, such a type of inheritance is called what? Right. Single inheritance we can call. Single inheritance we can call. Single base class. This is called a single base class. And what? Single derived class we can say. Are you okay with this? I hope it is clear for you. 1 minute, ma. I will just take this side. So I'll try to. Fine. So I will try to. Okay, let it be. I hope you can understand this. Single base class and a single derived class. And a single derived class is comes under what? Single inheritance. Then after that, one more type of inheritance I would like to define. Here only I would like to give you one more type of form diagram. One more type of inheritance I want to explain. That is, second type of inheritance is multi-level inheritance I want to explain. See that multi-level inheritance? I would like to give you here itself multi-level inheritance. Here I am giving second type of inheritance. All these things I will show you programmatically, students. Then there I am going to explain multi-level inheritance now. So there I will give you the clarity on this multi-level inheritance. Observe it. So I will take it multi-level inheritance now. So let us. So coming to this place. Diagram as well as definition. And this is a regularly asking question. Try to be careful enough. How to answer it, I'm going to make you to understand. Try to look at. Definition, I'm going to make you to understand here. Very, very easy. Very, very easy. So definition I'm going to create. What is it? First one, observe ma. This is my class. This is the class I am giving. Okay, anyhow diagram I will give you. Observe it. This is a class C1. Next is called another class I will take it. C2 class I will take it. And then next I will take C3 class. C3 class I will take it. Tell me now, in this case, here it is called C1. Here it is called C1. Next is called C2. Next is called C2. Next is called C3. Next is called C3. Then I am going to take up here C1 to C2, C2 to C3, C2 to C3. Then I am going to take up C1 to C2, C2 to C3, C2 to C3. Here I am going to give you the clarity on this area. So here C1 is called which class? Quickly. Super class I am going to take. Just consider C1 and C2 once you consider more. C2 class is called what? Quickly. Subclass. Very good. It is called a subclass. Okay. Subclass. Fine. And what is C2 and C3 you consider? C2 and C3 you consider. What is this class is called? Subclass. And C2 and C3 when you say, and C2 is called that type. Which class? Super class. When I take C1 and C2, C2 is a subclass. When I take C2 and C3, C2 is the superclass. So C2 is acting as what? Both a superclass as well as. So that type of class in Python is called intermediate base class we can call. Which class? Intermediate base class. Intermediate, which class? Base class. Intermediate base class we can call. What is an intermediate base class? In one point of time act as a base class, another point of time same class act as derived class. That is known as which class? Intermediate base class. What is C1 is called? Come on quickly. What is C1 is called? Super class. What is C2 is called? Intermediate. Yes, I will write it. Intermediate base class. What is C3 is called? Now tell me, how do you define multi-level inheritance? In multi-level inheritance, there exists single base class, single super class, I mean, single derived class. There is a chance of having multiple intermediate base classes. Am I correct? So that type of skeleton is known as what? Multi-level. So this inheritance contains, I am going to write it, students. See, this inheritance contains single base class, comma, single derived class, and what? Multiple or and intermediate base classes. In the bracket, yes, I will write it. I'll just try to adjust it. Did you understand this definition? This inheritance contains single base class, comma, single derived class, and intermediate base class or base classes. This is known as which type of inheritance? Multi-level. Well, now I will go for defining one more type of inheritance. I will go for it. What is the another inheritance? I will take it. Next, third inheritance is called what? Right. KK Gupta. Yes, ma. Thank you. Right. See, third point I'm going to give you. What is that? hierarchical inheritance. Hierarchical inheritance. Fine. Hierarchical inheritance. Well, so in this hierarchical inheritance, what is the diagrammatic representation? We see programming also on this area. We will see the programming also in this area. Every topic I am explaining programming. So there is no confusion in the programming at all. Okay, right. Come on to the point of it. Definition as well as diagram. Definition as well as diagram. I am going to give you. Definition as well as diagram, students. Look at diagram I am going to give you. Diagram. What is the diagram says? In this diagrammatic representation, you will be having a single class. That is, our class is the best example of what? Hierarchical inheritance. One teacher giving the knowledge sharing to multiple students. All the students in the class are what? Derived. Teacher is what? Base. So it is called C1, C2 and C3 and multiple classes we have. So on multiple classes we have. So I'm writing there. I'm writing there. What I'm writing there, ma? C1. Next I am writing here, there. What is that? C2. Sorry. C3. I will take it. C3. I will take it just a little bit. C3. This is called what, you know? C2 and so on. What, ma? Cn. Cn this is. Cn. Nth class it is. Nth class it is. What is C1 is called? It is called a superclass or base class, and it is giving to multiple derived classes. Multiple derived classes. Fine. So go to this place. Here I am writing multiple derived classes it is taking. Well, so I am taking here this one. I am taking here C3. Now I am taking here Cn. What is this C1, C2, Cn are called, ma? What classes? Yeah, subclasses. These are called subclasses. Subclasses. Did you understand? Fine. Simple. What is this type of inheritance is called? Hierarchical inheritance. A team leader in the company and many software engineers, they are comes under what? What they are comes under? Right. Is it hierarchical inheritance or not? Right. Like that we are going to see programming also. This is known as which type of inheritance? Come on to the point of it. Next. This inheritance contains, I'm going to write it. This inheritance contains single, which class? Superclass or single superclass or base class and multiple subclasses. Multiple subclasses is comes under what? Well, this is comes under one type of inheritance that is known as hierarchical inheritance. I will take it next. Which kind of inheritance? Multiple inheritance and hybrid inheritance I will take it. So is this diagram is clear, students, up to here? Is this diagram is clear? Up to 3 inheritances are clear? Very good. Good. Now, let us go to the next. Another screen I will take it. Another screen I will take it. I will go for 4th type of inheritance called what? Come on, ma. Multiple inheritance. Multiple inheritance. Multiple inheritance I am going to explain. So what is this multiple inheritance is? Very, very easy. Very, very easy. So I am going to write it. Multiple inheritance. So I am going to give you the clarity on this area. Here I am going to write it. Something like this. Let us take the diagrammatic representation. So here I am saying, let us see. Definition. Definition. And the next I am going to say diagram. Diagram I am going to give. What is the diagram here I am writing? Let us watch. multiple base classes, my dear students. Class C1, class C2, class C3, n number of classes are there. Multiple base classes are there. One single derived class is available. So I'm going to take C1, next is called C2. So on, I will take it. This is Cn. Cn. This is called Cn. I am going to take it here. I am going to take it here, saying this is coming into this place. So I am writing there C1, and next is called what you know? C2. I will take it here. C2. Cn. I will take it. Cn. I am taking here this one, and finally coming to this area called what? This type of values. What is C1, C2, C3 are called, my dear students? Are called base classes. So I will take it as what here, you know? Cn plus 1. Cn plus 1. N plus 1. So here is called what? Base classes or super classes. Super classes these are. Next is called what you know? Subclasses these are called. These are called subclasses. Subclasses these are called. Fine. So now subclass, only one class now. Fine. What is this inheritance called here? I just want to write. In this inheritance contains, this inheritance diagram itself will make you to understand. This inheritance contains multiple superclasses, and what? Single subclass is called which inheritance? Multiple. Next, last and final, hybrid inheritance I will take it. In some of the websites, they won't address that multiple inheritance and hybrid inheritance, but they are available. I'll show the programming also on this. When multiple inheritance come into picture, a lot of new programming will start in an easy way. Okay. If I say that multiple inheritance is not there, I can complete my inheritance in one day itself. So let us discuss multiple inheritance. In Java, multiple inheritance not supported directly by the classes, but it supports through interfaces concept. But in Python, such a type of problems are not there. It will 100% supports here. Okay, coming to the next point here. Why I'm saying Java here? Because in Java background, if anybody is there, they may think that multiple inheritance is not there even in Python also, but it supports. It supports. In Java also supports with the interfaces concept. That is different. That is different. Now I'm going to start with next one. I'm going to say, what is the next one? Hybrid inheritance I will go for discussing. Hybrid inheritance I am going to discuss. What is this hybrid inheritance is? Very, very simple. In this hybrid inheritance, nothing is difficult here. It is a combination of available inheritance types. It is a combination. Hybrid name itself says, the name itself says that it is not going to be one inheritance. It is a combination of multiple inheritances. So I'm writing a formula here. Directly I will write a formula. Definition I am going to write it. Definition I am going to write it. What is the definition here? Hybrid inheritance is equal to hybrid inheritance is equal to what is that? I can write next line better. Is equal to combination of any available inheritance types. Any available inheritance types. Any available inheritance types. So what are the available inheritances which are available? What are the available inheritance types which are available in Python? Single inheritance is there. So many number of other kind of things are there. Combination of any available inheritance types. So coming to the point of it, I am writing Diagram number 1. Observe it now. Diagram number 1, I will write it. Diagram. And there are so many diagrams you can prepare, guys. First diagram I am going to prepare. It is like this. So C1 and then C2. C1 and C2. This is called one type of diagram. Or better, I will write it like this. C1 and next is called what you know? C2. C1 and C2. It is called which type of inheritance? Tell me. Which type of inheritance? Single. It is called a single. After that, if you look at, here there is a C2, here there is a C3, here there is a C1, here there is a C2. Let me connect this. Let me connect C1, C2, and next this one, which type of inheritance up to this connecting part? Multi-level. And this part is called what? Multi-level. Multi-level. And this part is called what? You see the combination which I am going to. This combination, single. This combination, multiple. Hierarchical. Single and hierarchical. It is a combination of two. It is known as what? Hybrid inheritance. Simple, ma. Why difficulty? So I am going to write here C1. I am going to write here C1. Next I am going to write it here what? C2. This is called C2. C2. And below to this are called what? C3, C4. In this, how many combinations are available? Multiple combinations are available. If I take it, this portion, it is called a multi-level. This portion is multi-level. If I take this portion, single, and if I take this portion, it is what? Hierarchical. So many combinations are there. It is called which inheritance? Hybrid. Understand? One more diagram I will write now. One more diagram I will write it. Diagram number 2. Here only I will write another diagram. That is also one small significance is there for that. I will show you that. Diagram number 2. Diagram number 2. Yes, so what is this diagram number 2? So easy. You see, this is called one type of class. This is called one more type of class. This is called one more type of class. So here I am having these many number of classes are available. So this is called 2 classes. Fine. And I'm going to take this more. This is called one more type of class. This is called one more type of class I am taking. Now tell me now, in this case, what I am going to do? Here I am going to take it. Which inheritance up to here is ma? Hierarchical. And what about this one is called? Multiple. It is looking like a symbol called rhombus or not? Diamond. Yes or no? So diamond problems is forming in the inheritance. Generally, most of the people says it is not possible to support. But in Python, supports very well. Because Java, people will think Java OOPS features are, concept is same, but implementation is little different there, here little different. So don't think that those who studied Java anytime, and if they carry in Python, don't think that it is supporting fully here. So multiple inheritance and hybrid inheritance completely supports in Python language. In Java language, it won't support. In this case, it will support perfectly. So I will take it as C3. I will take it as C3. Here I will take it as C4. C4 I am going to take it. What type of inheritance it is? Hybrid inheritance it is called. Is it combination of multiple inheritances or not? Right. Are you able to get my point? So diagram number 1, diagram number 2. What these are all called? What these are all called? Types of inheritances. How many types of inheritances we have? 5 types of inheritances are there. What is the first type? Single inheritance. Next. Right. So there are 5 types of inheritances. All of them are defined. Students who are in the online, did you understand, students? Did you understand this explanation? Quickly. I should know this. Right. So next, I would like to go for further discussion. After that, This part I will send to you in the Google Drive class. Next, I need to go for syntax for inheriting from base class into derived class. I need to go for that inheritance. So that I have to explain now, or in the next class, we need to think about it. So today or Monday? Today or Monday? Monday. Okay, Monday. Next class, Monday. Monday. Okay. So all the students, Monday, sir. Okay. Rohit Jain, Vamsi, Syed, Monday. Sagar is only today. Very good. It's like my mindset. Sagar is like my mindset. Samir also like my mindset. Today, Brahmani also my mindset. KH only Monday. Rest of the days, no, only Monday. Very good. Monday, Rocky is also Monday. Offline students, Monday today. Monday, very good. So, right, ma, Vinith, tell me what is your doubt, ma? I have one doubt. What type of inheritance is not allowed in Python? Vinith, all types of inheritances are allowed. All types of inheritances are allowed. Rakesh, very good. Rakesh is very intelligent student. Sir, your wish. Very intelligent student. Good. Vinith Kumar, all types of inheritances are allowed. I will show each and every inheritance with programming. Okay, ma. Votes for Monday. Okay, Mr. Knox. Knox also intelligent student because keeping the responsibility on the SAR only. So we also will take some minutes, some 10 minutes. Sandhya, I told you now, ma, please install the Oracle by yourself because I don't have a complete knowledge on other than my subject knowledge. Like Oracle installation, it is totally not necessary. I did not work on it. So my thing is always programming languages. So that's what I said. You take the Oracle help from any Oracle installation persons. If you are there in Hyderabad, if you come to Naresh IT, we will install you. We will install Oracle in your PC laptop and we will give you. Sandhya, if you are there in the Hyderabad, right? Fine. So Monday is confirmed. Monday we will confirm it. Right. Okay. So Senapati, you told them 11 in G. So it is easy to install and work out. Okay, Senapati, very good. Okay, ma, Renuka, very good. Okay, wish you the same, ma. Wish you the same. Right. Right. Okay, Mahindra. My brother had saw the notes. He told notes is awesome. Very good, Mahindra Babu. Thank you. Thank you. Right. Okay, Ganesh Verma, it's my wish. So my wish is also like students' wish. Monday we will continue. What is the Monday? Syntax for inheritance. And on the day, programming I will teach completely. Many more examples we will teach on the day. Right. So now Ganesh Verma, tell me which diagrams I have to keep using. Types of inheritances are useful. Other diagrams are useful. So these diagrams I will send to you. Okay, na? Other diagrams which I just drawn, only rough work I drawn. Okay, right. So take care of this. This type of diagrams I will send you. Shall we stop the class? Monday class, we will go for it. Thank you. Good day. And Monday, I'm having one new batch. New batch is there at 6 p.m. So far I have only up to 6 o'clock I have the session. Monday I have what? 6 o'clock. New batch is there. Any friends, you can intimate both online as well as offline. So Monday we will meet it. Fine. Thank you. Good day. No ma, 6 o'clock evening, Rocky, evening time, 6 p.m. New Python batch. Intimate to your friends. Thank you. Good day.